Well, happy Mondays, 5th grade. Hope you're doing well. Today we're going to be looking at L104, converting mixed numbers to improper fractions. And so we're going to kind of take that as a just out of context skill, and then we're going to bring in, well, why do we bother? So the word conversion is something that I'd like you to use when talking about this idea. We use conversion when going from different units of measurement to another. We also use it here. So when we take a mixed number and we change it to an improper fraction, we are converting. So we're going to draw a little picture. So I want you to draw 3 circles, and let's shade this circle. Let's shade this. Don't overly shade it. Just shade like this, okay? And then I'm going to break this circle up, and then I'm going to shade this, and I'm going to shade this. And hopefully we would all conclude that the amount of cake, if you will, or the shaded portions would be, we have 2 whole circles, and then 2/3 of another circle. And this is very true. Now, if I was going to go to those same circles and break them up all into thirds, such as boop, 1, 2, 3, there you go, and boop, boop, boop. And then I was to count the thirds that I have. I would have 1, 2, 3, 4, 5, 6, 7, 8. 8 what? 8 thirds. And this is a nice visual way of showing how 2 2/3 is precisely equal to 8 thirds. So that's good, right? But if we had to draw pictures for everything we'd ever see, then that would be kind of problematic. So we want to be able to go from this 2 2/3 without drawing pictures and moving to that 8 thirds. And so we're going to use this 2 2/3 as a model. So here's a way to think about it, and I'm going to draw like kind of a little visual mnemonic. So you always start with the 3, and then you're going to wrap around that 2 in a multiplication sort of fashion. So you're going to take your denominator and multiply it by the 2. Then whatever that equals, you're going to add to this 2. So we'd say, okay, and then the key thing is that's going to equal something over the original denominator, over the 3. So, okay, let's walk through that. I would do 3 times 2, which is 6, plus 2, that's the 2 in my numerator, which is 8. So I wrap around, I'm like, okay, 3 times 2 is 6, plus 2 is 8. Therefore, 8 thirds, which is the answer we got before. Let's try it with this one. 3 and 5, 6. So remember, we're going to start at the 6. We're going to wrap around in a multiplication sort of fashion. So 3 times 6, we know to be 18. Then I'm going to add the 5, and I end up over the same denominators. So 3 times 6 is 18, plus the 5 is 23. 23, 6. And I box that up. And you might wonder, why do we need this? Oh, we're going to get there in a moment. But right now, I want you to practice this. And I've got 3 of them for you here. So what you're going to do with each and every one of these is, at least mentally, you're going to take that 5. You're going to wrap around in a multiplication sort of fashion. Then you're going to end up, whatever that equals, you're going to add that, and you're going to place it over the original denominator, okay? You do not have to draw the visual mnemonic. It's just something that's supposed to help you a little bit. You don't have to draw it. I do these in my brain. I go, okay, 2 times 5, blah, 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 blah. So I want you to pause me, and I want you to come up with an answer for these 3. So pause me, and then come back when you're done, of course. Pause me in 1, 2, 3. And hi, you're back. So 5 times 2 is 10, plus 2 is 12 over 5. 12 fifths. Box it. Next one, you should have done 3 times 1, which is 3, plus 1, which is 4, 4 thirds. Box it. Next one, you should have done 9 times 10, which is 90, plus 7, which is 97, ninths. Box it. And this little skill is important, and it's mostly important for problems like this. Imagine we were to multiply 1 1/2 times 2 3/4. Now, there's been a lot of Pavlovian responses that have happened over our year together. I got a new one for you. So whenever multiplying, we have to think about something that I call the crucial first step. And that crucial first step, hopefully you know what the word crucial means. It means like absolutely necessary. And whenever we're being asked to multiply or divide mixed numbers, we must blank the mixed numbers to blank fractions. Let's go ahead and fill in these blanks together. So let's all talk it out from when multiplying and must blank. Okay, on the count of 3. 1, 2, 3. When multiplying or dividing, must change. And I don't want change. I want a different word. Oh, yeah. Okay. When multiplying or dividing must convert. Very good. We're going to convert. And then sorry, I had to sneeze. Let's take it all the way through, class, on the count of 3. 1, 2, 3. When multiplying or dividing must convert mixed numbers to improper fractions. Yeah, we must. That's why we learned that little skill. And there's really no other way to do it. There's no other way. I'm not making this up. This is the way. So what I have to do is take this 1.5 and do what we did before. So we'd say, okay, 2 times 1 is 1, plus the 1 is 3, 3 halves. Now I'm going to multiply that. Let's do our 2 3/4. So 2 times 4 is 8, plus 3 is 11, 11/4. So basically we take mixed number multiplication and we turn it just into fractional multiplication. And we know that whenever we multiply fractions, we always want to look for cross-canceling opportunities. There are none here, so we get to multiply straight across, and you get 3 times 11 is 33, and 2 times 4 is 8, and we're going to box that up. And you might be like, wait, we're not allowed to box that up. Yeah, for the most of G5. Most of 5th grade life, you're not. But in 3rd trimester, we actually operate under a different principle. Because the way I see it is you're closer to becoming a 6th grader than you were to becoming a 5th grader. And so we're going to operate differently for the remainder of the year. And we're going to operate under this principle. We are going to box that up. And the reason why is because of this statement. Who can fill out this statement for us? Okay, go ahead. Susie Q. We love our improper fractions. Yes, we do. We love them. And I know throughout your whole math life up until now, you've always been asked to convert improper fractions into mixed numbers. However, moving forward in math, we really do want to hold strong and true on these improper fractions. However, there are a few things that we never do that, right? One is if they specifically ask us to convert into a mixed number, like an end answer. Secondly, in areas of measurement. So someone's height, a length of time, or anything like that, right? No measurement, improper fraction. We must convert to a mixed number. And then the last is if it's a word problem, because we just don't answer word problems in improper fractions. So those are the 3, but other than that, we're going to keep it. This is not this is not measurement. This is not, they're not asking us specifically to do it. And lastly, it is not a word problem. So let's do this. 3 1/4 times 1 3/5. Remember, we must adopt the crucial first step whenever multiplying or dividing mixed numbers. So we're going to take this 3 1/4, and we'll say, okay, 3 times 4 is 12, plus the 1, 13/4. We're going to multiply that, and let's deal with our 1 3/5. So 1 times 5, we know is 5, plus 3 is 8/5. And remember, we're always going to look for cross-canceling opportunities. Do you see any? I do too. So that 4 and the 8, right? Well, the GCF is 4, so that 4 is going to become a 1. That 8 divided by 4 is 2. No more cross-canceling opportunities, so I get to multiply straight across. 13 times 2 is 26. 1 times 5 is 5. And guess what? Claim it. Claim it. Claim your soon-to-be 6th grade status by boxing that up confidently, because I no longer need you to convert it back into a mixed number. Yeah? Kind of cool. Kind of cool. You didn't know that was going to happen, did you? It's happened. It has happened to you and to me. Hey, let's look at this situation. Cleon prepared 2 1/4 cups of food for his plants. Aw, that's so nice. How much should each of his 9 plants get? So he's got 9 plants. We do have to kind of move forward that Cleon loves his plants equally. So they're all going to get the same amount of food. So again, visualization is very important. Be Cleon or be a plant, I don't really care. But we want to realize that this 2 1/4 cups is going to be split up equally amongst his 9 plants. And that should lead us to a certain operation if we're visualizing. But operation? Well, hopefully your mind is screaming division. So what would we do? We'd say, okay, 2 1/4 divided by 9. Now, as we said, when multiplying or dividing mixed numbers, we must convert. So I'm going to take this 2 1/4, and so 2 times 4 is 8, plus 1 is 9/4, divided by 9. And again, another thing is that we have to think about that division is multiplication of the reciprocal. And we've explored that idea before. So we operate under stay, change, flip. So stay on my 9/4, the division will change to multiplication, and then I flip. So that 9 exists over 1. So when I flip it, it's reciprocal. I get 1/9. Are there cross-canceling opportunities? You bet there are. Boop, boop. Those both become 1s. I multiply straight across. I get 1/4. And then I will answer 1/4 cups of food or 1/4 cup each, provided that he loves them all equally, which I believe he does. Other than that, it is Monday. We did 103 on Freya's Day, so you do have homework. It's the split, HW 103, 104. Hope you're doing great. There will be a couple double lessons this week, just to forewarn you. You don't need to ask me why. I just make choices to benefit you. Okay, take good care. Take good care of my